mathematicians. I am Annalakshmi from V.H.N.S.N.College, Virudhunagar. Today we discuss about a normalizer. First we see the definition of normalizer. If A belongs to G, then N of A, the normalizer of A in G, is the set of elements in G which commutes with A. N of A equals X belongs to G such that Ax equals XA. That is, N of A, the normalizer of the element A in G, is satisfying the condition X belongs to G. The elements in G satisfying Ax equals XA. The collection is called as N of A, that is normalizer of element A in G. Okay. Now we see the lemma. The normalizer N of A in G is a subgroup of G. The collection set is, we prove that, is a subgroup of G. Now we see the proof. The proof is by using the theorem, a non-empty subset H of a group G is a subgroup of G if and only if A, B belongs to H. This implies A, B inverse belongs to H. Two elements take from the subset, then it is satisfying A, B inverse belongs to H, then we called H is a subgroup of G. Okay, we use this theorem. Okay, we have N of A equals, by definition, the set of all elements X belongs to G such that Ax equals XA. Now we take two elements from N of A. This implies x1 belongs to N of A. This implies Ax1 equals x1A. x2 belongs to N of A. This implies Ax2 equals x2A. We prove that x2 inverse belongs to N of A. The inverse of the element belongs to N of A, we must prove. Okay, we have Ax2 equals x2A. This implies both sides multiplying by x2 inverse. x2 inverse into Ax2. x2 inverse equals x2 inverse x2A x2 inverse. So this implies, we use associative law, we change the bracket, we get x2 inverse A equals A x2 inverse. Okay. The condition by definition satisfying the element x2 inverse, therefore x2 inverse belongs to N of A. Now our claim is x1 into x2 inverse belongs to N of A by using the theorem. A x1 x2 inverse equals A into x1 into x2 inverse using associative law, that equals x1 into A x2 inverse, that equals x1, changing the brackets, associative law, A x2 inverse, that equals x1 into x2 inverse A, that equals x1 into x2 inverse A. Therefore, satisfying by definition N of A normalizer definition, that element satisfying, therefore x1 into x2 inverse belongs to N of A. Therefore, N of A is a subgroup of G by using the theorem. Okay, thank you.